Welcome, everyone, to our kickoff stream for today's Cohere Hackathon. I am super excited and super happy to have you here and to be the proud MC of this event. You may have seen me in the past in one of our events, but today we're coming in way more energetic, way more hyped, and way more happy to be here. So without further ado, I think we should begin with our kickoff presentation. A little word about myself. I'm Alexander Jankowski. I am the Operation Partner Manager for New Native, who is the creator and founder of Lab AI. So I'm super happy and super stoked to be here. As you can see, my image has been just slightly upgraded using AI, just a little bit, because I know nature is very difficult to perfect further, but it's just one of the showcases that what you can do or how you can accelerate and improve with AI. So our schedule for today is our kickoff and introduction. We're going to tell you a little bit about what we're trying to accomplish through Lab, what we're trying to build through Lab, and that will be done by Paweł Czech and Matthias Asberg, who are the founders, and we'll have a little introduction about Cohere. After that, we're going to introduce, of course, the challenge and why we're all gathered here, show you a little bit on how to connect the Discord, how to set up the teams, and make sure you know everything about the event. Then we're going to go through generative AI in two parts. One of them is going to be run by Lewis, and he's going to have a wonderful presentation for us. And the second part is going to be run by Edward, and that's going to be a video. At 6:50 CET, we're going to be introducing language models with Sandra and the developer relationships manager at Cohere. And at 7:20, we're going to have a workshop on generating long stories with Cohere's API with Jay. We're going to give you some time at 7:40 to generate the teams, to form them, to build them, and hopefully to set them all up and meet each other in the Discord. At 8 p.m. sharp, we're going to get started with text generation with Mayor Amar. And at 9 p.m., we'll give you a little bit of a space to introduce yourself on the live Twitch stream. On Saturday, we're going to continue with a trivia competition at 2:30 p.m. And at 3 p.m., we're going to have a yoga break with our wonderful yoga master, Nasty. And at 3:30, we're going to have interviews with our participants. So if you're feeling up for it and want to spread some of your fame, make sure to be active and be on the lookout for the interview invitations. And at 6 p.m., we're going to have a coding battle, and where you're going to be faced with a challenge, and then we're going to be able to see exactly how good you can code and how fast you can think on your feet, because that one is going to be all about how you can improvise and how fast you can solve it, and whether you are the best coder and programmer at the event. All right, our Sunday schedule is fairly straightforward. We're going to go through presentation tricks and tips with Olesia, our social media manager. At 3:45, we're going to do a little video pitching workshop to help you out with submitting the best project you possibly can. And at midnight, we're going to have the end of the submission deadline. So please, please, please make sure everything is set up and go before then. What? We will be back shortly. For now, I'm handing it over to Paweł and Matthias.
Okay, I will send it in the chat.
I have it already.
Welcome everybody to our today's Cohere Hackathon. It's wonderful to be here. It's an absolutely phenomenal privilege to be your host for today. I'm Alexander Jankowski. I am the operations and partner manager at Unative, which is the founder and creator company of Lab.ai, which is the platform where this wonderful event will be hosted. On a day-to-day basis, I handle a lot of miscellaneous tasks for the company. One of them, I'm having the privilege of being your host for today. Our schedule is packed for today. We're going to be introducing Lab, mission, and vision. That's going to be covered by our founders, Pavel and Matthias. And we're going to go over what Cohere is, what the company is, what the software behind it is. We're going to introduce the challenge to you, show you how Discord works, show you how to connect your Lab AI platform with it. Then we're going to go over what generative AI is in two parts. One part is going to be live with Lewis. The second part is going to be a video by Edward. We're going to introduce you to language models by Sandra from Cohere. And we're going to have a wonderful workshop on generating long stories using Cohere's API with Jay. Then we're going to give you some time to form the teams. Hopefully, you're able to find like-minded people who share your interests and passions. At 8 p.m., we're going to be, we'll show you how to get started with text generation with Mayor. And at 9 p.m., we'll give you a little bit of a space and a place to introduce yourself on the live chat. Our schedule for Saturday is we have a wonderful trivia competition, lots of interesting problems to solve and answer. And then we're going to have a yoga break by our own Bali certified yoga master. At 3:30, we're going to have interviews. So if you're looking for a little bit more recognition and to be a little bit, more out there and have your project brought to our community, then be on the lookout for the interview information. At 6 p.m., we're going to have a coding battle which is going to be one of our means that we are intending to use to prove who's the master of coding at this event and who's the best thinker on his feet when it comes to coding. As for the Sunday schedule at 3:30, we're going to be presenting tricks on how you can make your presentation or your submission perfect. And this will be done by our very own Olesia, who's our social media manager. And at 3:45, we'll show you a little bit more on how to pitch via video. And at midnight is when we plan to close the submission possibility. So now I'll hand it over with pleasure to Pavel and Matthias, who should take you through what Lab AI's mission and vision is. Thank you.
Great. Thank you, Alexander. Pavel, maybe you want to start?
Sure. Yes. Thank you very much, Alexander. Hello, everybody, and welcome to our stream and welcome to the Generative AI Hackathon. So if you're here, it already means that you're ahead of the curve and you're top of your game. Just being here to experience the new models from Cohere, the new tools from Cohere is a tremendous achievement. So our job, together with our team and Cohere team, is to help you build the coolest new products and services on generative AI models. And this market right now, as you may know, is exploding. We expect that you will be building extremely cool applications. There's well over 1,000 people that will be building together over the course of these few days. So we really hope that we see true innovation, that we will see true inspiration coming from everybody joining, and that you solve some really difficult problems with your expertise and with Cohere toolset. It's great to see Cohere launching the new sandbox. And this hackathon is one of the first ways for you to experience it, for you to get access, for you to speak to the Cohere team. And it's going to be a great experience overall for us, for you, and for our great sponsors from Cohere. I would love for Matthias to just say a few words on his view of what is the future of generative AI and how it takes us into the next level of building software.
Thank you for giving me. No, just as Pavel said, it's a truly super interesting time. And, you know, I'm even to my friends that are doing other stuff, I'm like, you should really look at this thing. Like, even if they have other, like, work in different sectors, and I kind of know, okay, because we see where this is going, and from our side, it's no doubt that we are in a truly unique and very transformative time in compute, so to say, and yeah, the computer haven't been around forever, but basically it have been the same setup more or less from for a very, very long time, where we just continuously improved it consistently a little. But now everything is changing, and we can truly reach a very high grade of automation in many areas. But that might a bit sound very complicated. But what is so amazing with this technology is that it really opens the door for people to really build with it. So we see the people that are coming and attending this event, and it's really people from all areas. Many have a technical background, but we also see other domain knowledge coming, and it's super important for everyone that are sitting. Not specifically like we need a technical people, and we need them to actually realize this, but we also need people with different domain knowledge that are doing different things at the computer every day. Many of you are sitting on really, really good ideas. Anyway, enough about that. We are super passionate about just empowering this transition, and we are just trying to create things that basically will help out to accelerate this adoption by having various platforms and frameworks out there that we anyway truly try to adapt for this new frontier, we can say, of the way we build and operate software. Yes, super excited to see what all of you are building during the weekend with Cohere. They truly have a amazing set of tools, and they have put a lot of effort in also building boilerplates and things you can use. So make sure to go in at their GitHub and check out the things you can find there. It will be super helpful. Pavel, do you have anything more you want to say? Do we leave?
Sure. So I just wanted to say a few words about lablab.ai. This is where we invite everybody to come together, as we are all builders, and we are far better building together, creating amazing things together. So lablab.ai is created with the sole purpose of building new innovation with the state-of-the-art artificial intelligence tools and models. We prepared for you with love tutorials, boilerplates, templates of various tech that you can access straight off the bat. So please check out the AI Tech page, specifically the Cohere AI Tech page. You will find those links in the Discord as well. So that's very important. There is a team of mentors waiting for you to answer any of your questions. And very importantly, even if you came to build solo, or if you came with a team, there is the ability to find like-minded people very, very quickly. So just jump into the I'm looking for a team channel on the LabLab Discord, or just jump into a team on the lablab.ai platform. From that level, you can basically find people to build with. We are expecting literally hundreds of teams and dozens of projects submitted. And we are here to support you throughout this process. So LabLab is there for you, and so is state-of-the-art providers like Cohere. We invite you to go through the structure today with us, understand what exactly is going to happen, and you will be able to build really cool stuff.
Yeah, let's see. Well, not let's see. Let's see on at the end of this event what people have built. But so far, we can see people are building amazing stuff. We are like mind blown every time, and it's a great time to be a maker. It's a great time to be in this specific field. If you are here, you are at the right place at the right time. All right. I think we talked enough, Pavel. So let's leave the word over to Alec again.
Thank you, guys. That was a wonderful introduction, and I really think it encompasses the spirit of LabLab AI. We want this really to be a space where people feel good, that they can find like-minded people and really, really make a difference through what they build. So let's on over to the next slide of the presentation. What is New Native and what is Cohere? So New Native is essentially the company behind LabLab that Paavo and Matthias represent, but it's also so much more. What we're trying to do is we're trying to bring AI and innovation through any of our initiatives closer to the developers and enable them to use these state-of-the-art tools at their own discretion and to learn them. And the important thing about that is New Native is meant to be the vehicle for any one of our other initiatives as well. Stay tuned for more that we do in the future. As far as Cohere, most of you that have joined this event have probably in some scope heard about Cohere, but Cohere has created these incredible, I think we've mentioned it a couple of times already, but I'm gonna keep repeating it until we're all tired of listening to it. But these language models, they are really good. We've seen all sorts of creations done with them, like from reading books and summarizing really, really long stretches of text to, stretching out things that like bios and write stuff for me. It's incredible what this software can do and what it can possibly replace and encompass in the future. So I'm super excited that Cohere has given us this opportunity to use it. The challenge for this hackathon is to use this API and to be as creative as possible. We're really looking forward to how you can surprise us. It's always the best option to give you the creative freedom to become your own Picassos or your own Da Vincis in the way that you can have the creative freedom and let the juices flow and just figure out how you want to do this. If you want to put it into a more of a commercial direction, go ahead. If you want to make it something just fun to use that you're planning to let everybody else in the world tap into and have their own fun, go ahead. Like, we are not limiting you in any shape or form. Of course, the technology that we are going to be using is the Cohere NLP API. And to use it, use this Cohere AI /sign up link, as you'll be able to handle up to 100 calls per minute for free of charge, which should cater to a vast majority of our needs for this event. Yep. For those of you that have joined us and haven't really had any prior experience with Cohere or haven't used AI too much, head on over to the tech page that we have created. So we've got one on the Lab AI website, and we have a section for dedicated on our Discord. Those are the two places that you can pretty much start to learn about Cohere. As it has been already hinted and introduced by Pavel a little, Cohere has brought to us Sandbox, which is a collection of GitHub repositories that should enable people who have varying degrees of ML experience to really use and tap into conversant, grounded QA, toy semantic search, route generation, and topically. Hopefully, you'll put this sandbox to its maximum use, and you'll really show us how it can be used for the good of a project. So we highly encourage you to build your applications on Streamlit and Replit, as we've seen the largest, how should I say it, results on those two. But of course, if you would like to use a different one, we do not put requirement or like a solid ban on top of it. It's just that these we found to be the most effective. All right, so we've reached the generative AI intro by Lewis. So Lewis, I'm going to pass it over to you.
Hello, can you hear me and see me?
Yes, we can hear you and we can see you.
Great, so I'm going to share my screen. So do you see the presentation here? The actual presentation?
Yes, we can.
All right, perfect. So yeah, let me know if the slides don't move or something. So yeah, thank you very much for such a wonderful introduction for such a wonderful event. My name is Luis Serrano and I work at Cohere. I'm the lead of developer relations team. And today I'm going to tell you a very quick and fun and non-technical introduction about generative AI that will be followed by a video by Ed where he explains it more in detail. So this is my favorite example of generative AI. It's this one. I don't know if you've seen this page. It's called whichfaceisreal.com. And it puts a real face of a person and a face that is generated by a computer. So who wants to take a guess of which one of these two is the real person? And I don't know if we can get people in the chat to say something, or if you guys among the stage want to take guesses. I see people in the YouTube saying left. Very well, very good. Yep, everybody caught it that it's the one on the left. Mostly because I see another person right beside, and those are hard to find to make. The face is easy to make, but the background is hard. As you can see, the background on the right is kind of strange. Let's do one more. Which one of these two, left or right? See that this group is pretty good. It's got like an 90% accuracy. Let's see, what do you think of this one, left or right? So again, I see a bunch of, there's some right, left, right. So this one's more, this one's harder, right? Actually, I wouldn't be able to tell, but if you see on the top left, there's some letters. Those letters are impossible to create in the background with that. These are used with GANs that actually wouldn't create it. So it's actually left. So you see, so that shows how good generative AI is, and this is from a few years ago. This is not even the state of the art. So it's fascinating. There's also obviously what Cohere does wonderfully, which is things like text generation, text summarization. So here's, for example, a prompt. You give it a prompt, so it's going to generate a blog, a first paragraph of a blog. So you can say how to get started with rock climbing, and the audience is athletes and the tone is enthusiastic, so it generates something pretty enthusiastic and for athletes, right? If you're an athlete looking for something, blah, blah, blah. But I can change the prompt. So there's actually a lot of what you learned here is going to be a lot of prompt engineering, how to make the best prompts to get the best. So I'm going to say how to get started with rock climbing. Audience is mathematicians. I can make fun of them because I'm one of them. And then the tone is angry. So it wrote this, and it does sound angry. I feel the need to vent about the people who write in to ask blah 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 blah. So it is truly fascinating what these things can do in terms of text and image. But let me give you a bit of an idea of machine learning. So there's many types of machine learning, but the one you may have seen, the two big types are classification, which is a type of supervised learning, and generation, which is what we're gonna be working, and that's more unsupervised or semi-supervised learning. So what is classification? Well, it's answering yes, no questions, right? So you have, and generation is creating new data. So classification, let's say you have the model in the middle and you put in things. So you put in, for example, images, and the model is supposed to tell you if the image is a face or not. And so a good model will say yes for an image if you put in a face, and if you put a truck or noise or anything else, it will just say no. Whereas a generative model is different. This particular one, for example, has no input whatsoever, and you just press a button and it generates, if you give it data of faces to learn, it generates a face. If you press the button again, it generates a different face every time. So as you can see, it's much harder to do the one in the right than the one in the left, both for a human and for a computer. And the same thing happens with text. For a text classification can be anything that answers a yes/no question. For example, sentiment analysis. If you have a sentence, I'm having a delightful day, the model will say, yeah, that sounds like a happy sentence. And if you put something sad, it'll say that's a sad sentence. And this have many applications. For example, spam detection, right? Like if you put in an email that says, oh, this sounds like spam. So numerous applications. And generation, you can also do things like now you enter a prompt. You can say, for example, tell me something about a happy day, and it'll write a story about the happy day. The sun was shining, the grass was growing, etc. Like the blog post that I showed you before as well, right? So again, much harder to do generation than classification, because it's much easier both for a human and for a computer to say yes, no to something than to create stuff out of nowhere, right? And as you can see, there's two kinds here. The first one has no input. I just press a button and a new face appears. I don't tell it anything. And the second one has an input, which is I tell it what to write about, right? So those are two types of generative machine learning. The second one is called conditional generation, and both are useful, but conditional generation is just much more hands-on useful, right? You can say, I want to write an email about this, I want to write a tweet about this, I want to make an image about this, make a logo about this. So it's just much more useful. So then that's the one we're doing today, and that's the one we do here in generation, right? So there are many other applications of AI. So here's you can actually generate images with a prompt, right? So here's one, a photorealistic picture of a cute cat wearing a suit, typing on the computer, high quality. You can put anything and it's just gonna generate some amazing images. This image will appear, make an appearance later in Sandra's talk. You can also generate video. This is just more in the research stage, but and believe it or not, there's a video there. It was in weird format. I couldn't actually embed it, but the dog is actually flying, believe me. And you can put the input, right? A dog wearing a superhero outfit, etc., etc. Some things are more that you can actually generate code. If you go to this app dbuild.co, you can actually put in the instructions for what code you wanted to write, and it'll write an app with that code. Obviously, simple stuff only, right? But that's fascinating. And a recent research development that I found pretty fascinating, less visual but pretty fascinating, and is generating solutions to problems. So let's say you're solving an optimization problem, for example, portfolio optimization or mapping or something like that, and you've managed to find a bunch of solutions on your own. Like say you have 1,000 solutions that are pretty good. You feed them into a generative model, and then you press the button and spits out more solutions. And many of them will be garbage, but some of them will be actually pretty good solutions. So with that, some researchers have been able to actually beat the state of the art in portfolio optimization using just a blind generative model that just receives data and spits out data that looks a lot like what they receive. So it's pretty fascinating, and applications are just numerous. And just to give an idea of what models there are, GANs were the sort of state of the art, the ones that generate these images by itself. And when it comes to conditional generation, stable diffusion is really what's really generating these amazing images from prompts. And for generating text, we use transformers, which are very interesting architecture. It can do anything: translation, writing blog posts, summarizing articles, etc., etc. So that's pretty much all. I wish you all the best in this hackathon. I hope you have a great time. I hope you learn a lot and are able to create amazing demos that we'll enjoy later. So here's the time for Ed's video. I'm gonna stop sharing here. If you have any questions, feel free to ask them in the chat.
All right. Lewis, thank you very much for that. That was absolutely wonderful and great. I always wondered to myself, like, what are the practical applications? And it's really good to see, especially like I loved your use of the face generation, because we see so much AI generated artwork nowadays. I mean, I cannot go to a event or conference and not see a PowerPoint presentation that uses some kind of AI generated images. But it was your use that had us choosing between the two faces that I think was fabulous. And every single day I have the privilege of being a little bit surprised by how AI can be applied. And this is a perfect example that you took a technology that's, exists, and you've just made a really simple, puzzle or game out of it. And that is exactly what we want this event to be. We want people to take what exists, put a spin on it, put their own way, hack it, prompt hack it, change it a little bit, and come out with a completely different application. We've really seen technology across time become fundamentally remixes of the knowledge that we possess. And in certain applications, they become revolutionary. And that's what we absolutely wish all of your creations to become. So without further ado, I think let's jump into Edward's video.
Hello, and welcome to the Generative AI Hackathon. I'm Ed Greffenstedt, Head of Machine Learning at Cohere, and today I'm here to talk a little bit about generative AI, what it is, why you should care about it, and the sort of stuff that, hopefully we're going to help you build during the next few days. So to jump right in, generative AI is the subfield of artificial intelligence that deals with using and designing and creating generative models. And generative models are statistical models that allow you to sample or generate some data from a particular domain. So, for example, text from one or more languages, images, code, etc. During the rest of this talk, I'm not going to really go into the math or mathiness of these models. And so if that part of generative AI is something that you are not very familiar with, don't worry about the mathematical language surrounding this. You can think about these models as black boxes that you can produce new things from, images or text, perhaps controlled or conditioned on inputs that you provide to the boxes. And so these statistical models, these black boxes that you sample from, that you generate from, encompass the regularities or the patterns or other information from the domain. Commonly, they are large neural networks that are trained by consuming data which exemplifies these regularities or these patterns from that domain. And the nice thing is that thanks to companies like Cohere, Stability, OpenAI, you don't actually need to understand how this is done, how these models are produced, how they work internally in order to use them. Although it doesn't hurt if you do understand this, because it will give you strong intuitions about what their strengths and limitations are and how to get them to behave how you want. But hopefully part of this talk is going to give you at least some of these intuitions and help you get started. The data that you put into these models when you're training them affects what they're going to be good at generating. So for example, a generative model learned from English text as input data when we're training it is going to be good at generating more English text. Probably not going to be good at generating Korean or images or Python code. Conversely, a model that's trained on images is probably not going to be super good at generating text. A generative model learned on a sort of subdomain of one of these modalities, for example, predominantly learned from legal text, is also going to be good at generating more new legal sounding text rather than perhaps, conversational chat about, mathematics. Now, the process of being able to take a black box and sample new images or new text from it sounds pretty cool, but on its own, that's not very useful, because you probably want to direct the model towards the sort of thing that you want it to generate, the sort of like thing you want to create. And so that's where we come into this notion of conditional generation. Remember, I said these models can be thought of as black boxes which you can provide some conditioning input to. So conditional generation is this very notion. It's the process of generating something from the model conditioned on something else. For example, generating an image given a text description of the image you want to generate. Given the start of a paragraph, generate completions of the paragraph. Given some instructions, produce responses that execute the instructions. Now, why would you care about generation or conditional generation? Why should we be, learning about this in order to build things? Well, it turns out that many, or perhaps most, intelligent tasks that we do as humans in our jobs and our daily lives actually fit this pattern of conditional generation quite well. For example, drawing a picture given an idea that you have, whether you verbalize it as text or you have it in some sort of conceptual space in your mind, is a form of conditional generation, as is deciding what to say next in an everyday conversation given what's been said so far and the sort of broader context of the conversation. Providing advice given the description of a problem, or writing an effective, efficient computer program given some specification or some goal, are also good examples of this. Really anything where, you have information about the world or about the particular context, and then you need to act to produce something in return, actually is a form of conditional generation. So the possibilities are really endless if you have powerful generative models capable of conditional generation. Today, we're going to be focusing primarily, or solely, in fact, and for the next few days, on text generation, which is the process of generating more text given some other text, conditioning the generation itself. Now, you're not going to need to worry about the training or spinning up or serving of the models, the large neural networks that are capable of doing this for you. And instead, we're going to be using Cohere's models. And since I'm assuming you have a certain degree of freedom as to what you do during the hackathon, you can use whatever other tools and generative models you can find if you want. But Cohere's models are trained and served via endpoints with language-specific SDKs, such as a Python SDK available for your convenience, and they allow you to do conditional generation of over English currently, and eventually other languages as a modality. So there are two components to this process of getting text out of a model. There's the prompt, which is the element which you, the developer, give to the model, and that can be something that you've handwritten. It could be something that's dynamically produced based on the user input of your application or service. But that's the element that you have control over, which conditions the model towards producing a particular kind of generation. And then the generation itself, what you get from the model in return for your prompt, is what we refer to as the response. So how can you prompt your model to do things? Well, unmodified large language models respond to prompts by continuing them in most cases. So you can think of this as a very fancy autocomplete. Prompting, for example, a model with the prompt. The cool thing about machine learning is implicitly we'll obtain continuations such as are shown in this little code snippet I typed in using Cohere's API. So it completed that sentence as the cool thing about machine learning is that the algorithms will always be learning and improving as they're exposed to more data, which is true. So this exemplifies the ability of the large language model to continue my sentence beyond just a few words until the end of sentence, in fact. You'll note here in the call I made that I told it, gave it a stop sequence. I said stop generating when you hit a full stop. If you remove that and you increase the max number of tokens, you can generate entire paragraphs, you can write your entire essay. Obviously, there's the potential for the generation to go off track as it goes along, but that's something you'll have to learn by experimenting with it. But it's astounding that you can produce these full sentences, full paragraphs that continue the style and topic of the prompt you give them. But beyond just treating them like fancy autocomplete, you can also, in a sense, teach them the reason through examples. So because they want to, these models want to continue to slightly anthropomorphize them. They want to continue the patterns that they see in your prompt. If you give them a pattern that has some structure, like here I go for this pattern of some data, a line that has a query, that's the index of the word I want to return, and then the result is, in these examples, the correct word to be returned. So I gave the model through the prompt a number of these examples of querying into a string. And the final such example is a new sentence that wasn't anywhere else in the data. I'm looking for the fourth word, which is actual. And I prompt the model, I finish the prompt by saying result : and then telling the model complete this entire sequence by giving me what the next word should be. And then when I run it, I see here that it does the right thing, which is that it, the prompt is quite long and the response is quite short, but it is in fact the correct word. And this is an example of how, without further training of the neural network, just through the structure of the prompt, science we call prompt engineering, I can actually induce this fairly structured behavior in the model with something it's not at all trained to do through a few examples. And that's quite a powerful ability that these models have. So this notion of being able to teach them on the fly through examples is powerful, but it might not seem extremely natural. We're used to talking to one another in goal-directed situations by giving each other instructions. So ideally, you'd sort of want to just be able to tell the model what it should do. So could I just not just tell my model what to do, give it instructions? And the answer is no, but yes. No, in the sense that most of the basic, even large, high-performance language models are trained to continue a sequence, as we've seen. So to get them to behave in a particular way, you have to prompt them by induction or analogy, as we've seen in the previous example. They're not trained to take an instruction and then actually understand, interpret, and execute the instruction. But there are specialized variations of these models, like InstructGPT, OpenAI DaVinci, or Cohere's own new command model, which you'll have access to during this hackathon, which take instructions as prompts, and the behavior is significantly different. For example, I can give the model as a prompt, write a 3-sentence paragraph about how machine learning can be used to generate language. The code that I wrote here is very similar to in the other examples, except as a model now I specify command x large, which is our command model. And when it reads this instruction, it produces as a response something that isn't naturally a continuation of this so much as it is actually following the instruction by writing exactly 3 sentences and then stopping. Note that these models actually do have a pretty good internal notion of when to stop based on the instruction, so you don't actually need to give them stop sequences. It automatically stopped after emitting 3 sentences. You can even ask them to do more procedural things like count from 10 down to 1, skipping all multiples of 4, and it almost does the right thing. So it skips 10. Obviously, I forgot to mention that, but it skips 8 and 4 correctly and somehow skips 6, which it thinks is a multiple of 4. So it's good to be aware that these models aren't sort of oracles, but that it's almost roughly following the instruction with no sort of actual example, just from its internal knowledge and ability to interpret such instructions. You'll note that for domains like this, where the instructions are pertaining to something much more formal and structured rather than exploiting the regularities of natural language like English, that there's scope for mistakes. So it's good to bear that in mind, that they'll work significantly more robustly at instructions about language than about sort of data. But it's surprising and quite magical that they do so well on even these sort of like very data-centric prompts. So to wrap up, where should you go from here? Well, you should experiment with which form of prompting that we've discussed suits your needs and suits your project, and how to form and manipulate prompts and responses based on what you're trying to achieve and how you're incorporating user input, etc. But ultimately, because it's just text in, text out, you have an astounding amount of freedom here with regard to how you're going to incorporate these calls to large language models, this ability to generate text condition on other text and manipulate its meaning, its structure, its ordering, and how you incorporate this into your projects. So, as I just mentioned at the end of the previous slide, it's good to have this caveat that these are not magical know-all models, right? But provided you're conditioning them on something which exploits their knowledge of the regularities of language, specifically English in the case of these models, the results really can't seem magical. You can produce processes which almost do seem to understand the language, and baking that ability into the applications, into the services, into perhaps the products that you want to build really unlocks a whole new dimension to play with and to get creative with. So I really look forward to seeing at the end of the hackathon the cool stuff you all have built. But yeah, go at it and happy hacking. Thanks.
Hi guys. So that was a pretty informative video. Thanks, Ed, for that. And if you'd like to pick his brain, let me just get out of the way here so you can see him. And we invite you on December 8th at 12 p.m. EST. You can ask him and follow up with any questions you may have towards what we've just shown you. And there should be a lot of questions. At least I know that I have more questions now after that one. Okay, and now we have an introduction to large language models by our very own Sandra from Cohere. Sandra, as always, it's an absolute pleasure to have you here. So I feel very confident leaving the stream and our guests in your hands. So take it away.
Awesome. Yeah, thanks for having me. And welcome, guys, to Generative AI Hackathon. I hope you are having amazing educational experience so far. I'm going to talk to you today about the basics of large language models, following up on what has been said so far. All right. So I actually want to start with the picture that you might recognize from Lewis's presentation on image generation. This is a photorealistic image of a cat that I generated today for the purpose of creating a meme. We hopefully all love memes, at least many of us do, and I think it will be a fun warm-up to get going. So I'm using this demo called Meme World. I'm going to show it to you at the end. But I just cherry-picked one example that I particularly love to create a meme, so let's do it. First up, we use the generative image to insert it into the app, and then we choose the type of subject that we want to create a meme about. And hopefully in the backend, Cohere API is generating a handful of cool startup-related memes and will give us something like this. When your startup gets funded and you can finally afford a new laptop. If any of you has ever created a project of your own and launched it as a startup, you might probably recognize yourself in this photo and meme. So then I put it together and voila, we have a cute meme entirely created by the generative AI. The demo, I'm going to share the link with you later on, is hosted on Hugging Face, and the gentleman that has created it is actually part of our community members and can be found on our Discord and is looking for contributors. So if you want to continue work on this one, please, by all means, connect and get going. All right, but on a little bit of a more serious note, language processing technology has been rapidly evolving and improving for the last couple of years. And it's actually all around us. Here you can see a number of applications that you may or may not be using on a daily basis. Well, for sure, at least the Google search is something that we all use on a daily basis and would be lost without. Whether it's autocorrect on your phone, whether it's automatic reply on your email, whether it's a snippet that comes up with a Google search containing the exact information that you were looking for, this is our reality and we are just surrounded by it. And language models are starting to deliver some of the best results in these use cases. As you can see, the big tech guys are really after it, but not only them. We have a whole new ecosystem of startups being created with the use of the latest language processing technology. And the applications span from copy generation to next generation of chatbots to next generation of search. It's really inspiring to see the startup ecosystem blossoming, and it's a great time to build new and competitive stuff. So we also have a first unicorn. In October, Jasper raised ginormous Series A round at a whopping $1.5 billion valuation, which makes it the first ever unicorn built off of large language models. About me, I'm Sandra. I'm looking after community at Cohere, but I also am running a YouTube channel where I explore large language models. I also write about them. I really went down the rabbit hole, especially in terms of the generative models, the GPT-based models. And so it's been a fascinating journey for the past couple of years, and I want to share with you some of the stuff that I have learned. As I mentioned, I look after community at Cohere. I'm part of the developer relations team, and I really love my job because we at Cohere are working on large language models wrapped in the form of an API that allow devs around the world without any machine learning / AI background to use these cutting edge large language models and create new stuff out of them. And I get to work with folks that are deploying these models into production on a daily basis into real world use cases. So let's chat a little bit about that. But before, I also want to talk to you about the sort of origins of large language models. Here you can see a paper called Attention is All You Need, a research paper published in 2017 by Google Brain folks, which became extremely famous and changed the face of natural language processing field forever. It introduced architecture called Transformer, which is the foundational architecture for all these large language models. And one of the team members is actually Aidan Gomez, who happens to be our Cohere CEO and co-founder. Once he published the paper, he quit Google Brain and he started working on creating an API that will allow for the access to these models to anyone, anywhere. I think this is probably the best resource that I have found on large language models and on the transformer architecture. If you're looking for a more digestible, very nicely illustrated resource on what transformers are and how they work, Jay Almer has this fantastic, famous blog that you have to check out, connected with his YouTube channel. Jay's actually also part of Cohere, and he will be having a workshop right after mine. So stick around and check it out. Make sure to check it out. But yeah, a little bit more about these transformer-based models. These are basically huge neural networks that are trained on massive amount of data coming primarily from the internet. And somewhere during the process of trying to make them better and better, the researchers found that when you start scaling the amount of data you use for training, the amount of the architecture, and also the amount of compute that you use for it, these models start to show the very, very interesting and very new capabilities that were unheard of in the research space before. And here you can see some of the key use cases that large language models are covering today. Among them, there is search, there is text generation, text clustering, text rewriting, summarizing, classifying, extracting, all sorts of stuff. And it really calls for just using these capabilities, building on top of these use cases, and just coming up with new types of products and new types of solutions. Okay, let's talk about text generation for starters. So at Cohere, we are working on GPT models that generate text and that you have heard a little bit about from Ed and Louis before. So these GPT models are first and foremost known for being able to generate text that is either as good or even better than text generated by humans in seconds. The way they work is pretty intuitive. You just need an input text, and as an output, you also get text. And what they are is, I like to use the comparison of autocomplete. It's like the world's best autocomplete, so to say, that tries to understand that given the input of text, what will follow as an output? What will be the most probable continuation of the text that you just inputted to the model? Now, when you are working with generative models and you are generating text, it's important to make sure that you test it out a bit and you generate a handful of outputs and choose the best one that fits your specific use case, your specific task. I want to show you very briefly how our playground looks like. It's a simple, very intuitive sandbox for our models, which allows you to interact with them without the knowledge of code whatsoever. So I encourage you to play with the generate, the embed, and classify endpoints that I will talk about a little bit later. And I really encourage you to go and check out the workshop on generating text with Cohere that will be hosted at 2 p.m. ET on Saturday by Mior from our team. So definitely, if you want to dive deeper into this capability, check it out. So I just want to leave you with also one key idea here, which is prompt engineering. With generative models, we have found that there is a completely new paradigm of interacting with them and of writing software called prompt engineering. It's basically like talking to the model, trying to sort of cast a spell so that the magic will happen on the model's side. And it's really important how you structure the prompt. It's really crucial what sort of instructions you provide and in what fashion. And it will differ depending on the type of model you're using. Some prompts will be more appropriate than others. There are also specific phrases, specific structure of these prompts that it's worth to think about, and Mior will be tackling that during his workshop. So yeah, definitely check it out. Now, next to text generation models, we are also working with representation models. And let me start explaining what that is by showing you how to tell your computer how it's going. It's my favorite example. If you're asking yourself how to ask your computer what's up this is how to do it. Basically, we need to represent text in specific form using numbers in order for it to be able to process it. And a lot of this text today is being represented using Unicode standard, which also even encompasses emojis. And so far, numeric representation was useful but limited. Here is one of the examples of where it was used. So for example, if you wanted to check whether if you wanted to check whether the user's password matches a certain criteria to make it as secure as possible, you would be able to do that with the existing numeric representation array of tools. However, they did not encompass meaning of the text. And this is where large language models brought its magic component in the form of embeddings. Thanks to LLMs, we have now embeddings which work in the following way. You give the model a string of text, and the embedding model will turn it into a numeric representation of this text called an embedding. And this numeric representation captures a lot of the information, a lot of the context behind this given text, which gives us a lot of room to sort of maneuver and process this text further. For example, we can compare embeddings to one another. Once we embed a list of questions, we can compare two questions to one another and see how similar they are. So for example, how it's going will be 2% similar to when do you open, but 90% similar to hi, how are you? Why is it useful? Let me show you my favorite example of the embeddings sort of utility in the form of semantic search. So let's imagine that you are building a platform and you want to automate the customer support there. You have an incoming messages, and let's say there's a customer question about the product that you really want to automate responding to because it keeps repeating, it's in your FAQ, etc., and you don't necessarily want to have this human in between the person that asks and gets the answer. So with the embeddings, you're able to take this customer question, embed it, compare it to already embedded FAQ questions in your database, just like we discussed before. You can compare it in terms of the similarity score, and you can set a certain threshold, let's say 90% similarity, to then take the question that hits this threshold of 90% and then output it as a response. So in that way, the system is able to answer the customer question by providing relevant information from the FAQ without any need for human intervention whatsoever. It's pretty dope. Okay, so we can use embeddings and generation models to build classifiers. And text classifier is basically a piece of software that takes text and assigns a label to it. And I just want to leave you, I will not dive into details, but I want to leave you with the landscape of text classifiers that we have currently, which is quite diverse. You have for sure encountered a number of them in your life already. For example, spam classifier that takes care of our spam emails, toxicity classifier that does not let you to be toxic, whatever that means, however it is defined online, in online communities, in online conversations, for example. Or chatbot intent classifier that tries to figure out if you need the customer support, what kind of support is it that you need? Do you want to exchange something? Do you want to check how your order is doing? Do you just want to say hello? What is it? So these are the types of classifiers that are out there. And the most common use cases for classifiers that we see today are for customer service and content moderation, just like I mentioned. I want to also show you that at Cohere, not only we do develop these incredible models, but we also love to play with them on a daily basis. And so we come up with all sorts of cute demos that I want to show you today. First up, let me show you a demo that is still a work in progress and will be much improved, but I'm always trying to sort of show it. This is a Pokédex. It will take a photo of me and then assign a label. Out of this label, Cohere API will create a new name of a Pokemon, this case, Jomon, and then the description of what this Jomon is as a Pokemon, what it does, what are its habits, etc. So Jomon, this powerful Pokemon battles using its fangs. It usually does not release its jaws, so it cannot speak. Type, Psychic. An example of a fun app. Next up, Affirmation Bot, one of my favorite applications. So one of our co-founders, Ivan, loves affirmations and is extremely good at coming up with new types of affirmations. We actually, Adrian Morrison from our embeddings team took Ivan's affirmations and trained the model to come up with similar affirmations such as Ivan. And so now we are able to get this wisdom automatically within seconds without Ivan having to spend time on it. What would you do if you knew you could not fail? Next one. Every day, I am becoming the person I want to be. And so on and so forth. I'm going to leave you with these links so you can play around. Another really cool application is actually a hackathon solution that was at Major League Hacking, which is an interview application that allows you to prepare for typical technical questions that are related to the position that you're applying for. You first insert the position that you're applying for, then the app is generating a bunch of questions, and then the app is also scoring your questions against, whether they make sense, how short or long they are, how concise they are, what kind of lingo is being used, and so forth. So another great application. Here, Jay Alamar is taking embeddings to the next level, combining 10,000 Hacker News posts with text clustering. It's a really, really impressive demo that allows you to sort of search through the Hacker News in terms of the topics and keywords that are somewhat related to one another and see the map of the conversation that's happening there. A similar thing could be applied to Reddit, for example, or maybe Stack Overflow or something similar. Think of playing with the archives, internet archives of human knowledge that way and being able to sort of look at it from the bird's eye view. Pretty incredible. Yeah, and finally, it's this meme world, which you can actually find here on our community Discord. So if you hit up this fellow and you want to talk to him about working on the meme world, please do. He's looking for other folks. We also have a bunch of really cool demos on Cohere Discord under the project demos. One of them is the grounded QA bot. And what it does is it takes an incoming question and it's searching for the best first result online for it, comes up with the answer and also links to that answer. So let's try with, what is generative AI? And as you can see, the bot is working. By the way, if you're into Discord and into bots, we would love to showcase your demo bots here if you want. We can sort of make them available on our Discord. A lot of folks are interacting with these, so please have that in mind. We love to showcase the stuff here. We love to be on Discord and also sort of have the conversation there. All right, so we have the solution. I mean, the answer. Generative AI is the technology to create new content by utilizing existing text, audio, files, or images. With generative AI, computers detect the underlying pattern related to the input and produce similar content. Not bad. And then there's a couple of links related to that answer. You get the idea. Go and try it out yourself, or even better, build something similar. We have actually released the Grounded QA bot as a sandbox. So it's open source. You can take the base for it and then develop something completely new on top of it. Yeah, and so next up, I really want you to go and check out our Discord community. We are hosting a ton of community events there. We're hosting talks with people from the NLP ecosystem. So if you're really passionate about this subject, go and check it out. Also share the stuff that you're working on and tell us what you need. Maybe you need the technical help. Maybe you need promotional help. Maybe you are looking for team members. So yeah, just consider joining and use it as a resource to grow. And yeah, that would be it from me. Now, let me know if you have any questions. Checking on the stream whether there are any. There is a question whether Cohere API can work on predicting images. Can you talk a little bit more about your use case in terms of predicting images? If it's about image recognition, as simple as it sort of sounds, then no, we do not handle that at the moment. We generally focus on text-related use cases and try to sort of get as good as it gets in that area. Let me know if you have any questions, any other questions.
So that was really good presentation. I'm sure our community will. Oh, there we go. What features of Cohere would you advise to try out during the hackathon? There we go.
Oh,
got a question.
Yeah, great question. So definitely text generation. Definitely try out the command model, which is a recent release and it's really, really good. Basically, command model is like Instruct GPT where you are able to just like give it a single line of an instruction and then it will go and do stuff for you. So really encourage that one. And since hackathon theme is generative AI, it would be really cool to see a combination of different modalities on top of Cohere, I guess. So I don't know, Cohere API and Stable Diffusion, or perhaps text to voice. Go as creative as you want. We really want to see how far you can push the models. Yeah.
Okay, we've got also another question on what is your take on generative AI art, specifically animations made by Stable Diffusion 2.0?
Oh, great question again. I love Stable Diffusion. I think it's an incredible resource, and we are just sort of getting started in terms of discovering the potential for it. I know that it will only. I have spoken with Stable Diffusion folks, and I know that it will only get better from there. They're really doubling down on the different modalities, but including animation. I think Stable Diffusion 2.0 is like, I guess it depends what you're looking for. The previous version could be better than the newest version. I find it really useful to use the older version for generating images. I haven't tried generating animations with Stable Diffusion to compare the two versions, so cannot really help on that, but there's plenty of sort of comparisons online, so go and check it out.
Very cool. Maybe a final question. So Hamada is asking, do you have use cases related to industrial applications? So can you tell us more about how Cohere is used in industrial applications today?
Gotcha. Industrial meaning?
Probably commercial.
Commercial. Okay. So I'm not sure I can mention the names of the companies, so I will avoid it for now since I'm not sure. But we have customers that are using our models to, for example, improve the personal communication, online communication. So think about writing emails, summarizing emails, stuff like that. And another thing is that I noticed that with our customers, what they are working on is that they will try one use case, but they will also explore like a number of others because they, just start to discover the tools. So I think we will see many different ways in which Cohere is being used from one particular company future on, as soon as we can talk about it openly. Yeah.
Wonderful. And the Pokedex definitely made a mistake because that was a wonderful, wonderful presentation, and you are more than able to speak. So it was great. And myself particularly, I love when we combine different building blocks of artificial intelligence. So if we use Cohere to generate prompts, and then if we use Stable Diffusion to generate images, what kind of tool could we make? Could we make an infinite amount of artworks and publish them on the Amazon web stores and become billionaires overnight? Why not? There's just an infinite amount of possibilities here. So thank you very much for that workshop, and let's keep going. So up next, we have Jay, who will be bringing to us generating long stories with Cohere's API. So I'm really looking forward. Can we write whole books in Cohere? Can we generate really, really, really long, cool stuff? Is the future of writing essays and doctorates and bachelor theses and master degrees over for so many suffering students all around the world? Hopefully, Cohere will bring us a step forward. So Jay, the floor is yours, and I'll leave it up to you.
Amazing. Thank you so much. Can you hear me? It's great.
Yes, we can.
Okay, my voice is going out, and except if anybody stops me. Thank you so much. That was a great introduction to what I'm about to speak about. So my name is Jay. I work at Cohere, and I work on helping our developer community understand the best uses of the models for their use cases. And today I'll be discussing one of the most exciting, I think, uses of language models that I know of. And it, just like what was mentioned just now, it involves a bunch of different types of AI. So we'll talk about text, but we'll talk about image generation as well. Now, stories are a little difficult to create something that really works. That's why this one paper that came out of DeepMind this year was, to me, one of the most interesting papers, and I've been going over it quite a bit the last few weeks, and I'm happy to take you through it and the methodology it explains to you of how you can generate a story, how you can have AI help you generate a story and help you flesh out the ideas in your head. And it's a method that can generate an entire screenplay just by you describing your story in 2 or 3 sentences. But the beauty of it is if you use the AI as something that extends you, something that empowers your thinking and your ideas, you can let it generate the entire thing, but then you can also use it as something that triggers your mind, and you can edit the suggestions that it gives to you. So with that, let me start by sharing my screen here. And I would love to be sure that everybody is able to see it. Okay. So this is the paper. It's called Co-Writing Screenplays and Theater Scripts with Language Models. It's really interesting, and I've extracted the prompts and the methodology of it so you can actually go through it yourself and generate these stories with Cohere's models. You can go to Cohere notebooks. So if you search just on Google Cohere notebooks, you find this our notebooks repo on GitHub. Again, that's Cohere-AI notebooks. And you can scroll to the bottom, notebook number 11, and that will open up this Jupyter notebook. This is this environment where you don't need to install anything. You just need a browser with your laptop. You go in and you can interact with these models. Like you're going to need API keys for Cohere and potentially for stability if you want to create images. But I'll run you through this demo. So once you go to 11 and click the collab, you'll have an image, have this page open up with a lot of the example code. This is a general idea of how that story is generated, how this methodology of generating stories with language model is generated. Now, if you've used large GPT models, you might think that it's just something like this, or maybe kind of like this, where you have the playground and you add the prompt to telling the model to generate a story, and then you have the model generate it. And so your input prompt goes inside the language model, and then you have the output and the model generates it. And that could work for shorter stories, but for longer stories, it's probably not the best way to go about it. And it's not what a lot of authors actually do. A lot of them have an idea, have an outline that they don't start until they sort of flesh it out. And that's kind of what the approach is here. And so the idea here is that the first building block that we need is the log line. So you need to describe your story in maybe 2 or 3 sentences. And then from that, we'll use it to generate all sorts of really cool things. And so once we have the description of your short description of the story, we can generate a title, we can generate characters, we can generate the plot, and then the location descriptions, and then each scenes. So to do this, we first get to install Cohere and the Stability SDK. So this is to use Stable Diffusion. You can use Stable Diffusion other ways. You can download it and run it inside, but this is potentially the easiest way to get started with it. And then there's some code here that does some setup. This will ask you for your Cohere API key and your Stability API key, so you're able to use the AIs hosted or at Cohere and that Stability to generate this text from Cohere and the story and the images from Stability. Now, this is the log line. So this is the short description of the story. What I wrote here is a sci-fi cyberpunk story about 2 hackers who find themselves both the targets of a cyber intelligence agent who suspects them of stealing $3.5 million worth of Bitcoin. The 2 do not know each other, and neither of them recalls stealing the sum. So this is just a very short description of the story, and then we'll have the AI sort of blow it up. So the first thing we can do is just run this code to get suggestions for the title. And you can open this to see what the prompt looks like. So you can always look at the code and fiddle with it. But I'll just run you through the actual output of the model. So here you have 5 different suggested titles. Hackers, unauthorized access, 3.5 million. You can run it again to get 5 more suggestions. Until you sort of find a title that you are happy with. So this is a little radical here, cyber war. You have all kinds of options, and you can generate more and more as you like. We can glance really quickly at the prompt. So the prompt has a couple of examples, and then it just plugs in the description of the story here. And the examples are short descriptions of other stories and the titles of those films. And this is the formula that is used to for all of the prompts. But then let's say you like one of these titles, and then we end up kind of like here. So we have our logline, we wrote it, and then we have our title, we like it. We can continue to generate characters. Now notice that we know that we have 2 hackers and an agent, but we don't have any names yet, and we don't have any descriptions. So what can we do here? Can we have some help from the model to generate characters or ideas for characters that can carry this story forward? Now the model is going and generating this in the background. We can take another quick look. So it's an example, and this is an example from Star Wars, where we have, let's say, 5 characters, and each character has a description as well. So this is the first suggested list of characters from the model. So we have hacker number 1, so white hat hacker, newbie to the dark web. And then hacker 2, we still don't have names, but we have descriptions for them. There's a Bitcoin locker, which is a virus. Okay, so that is adding a little bit of an interesting idea to the story. And then you have some more information about the agent. Suspicion. Okay, suspicion is a specific character here, it seems. So if you like any of these ideas, you can just, so I like, let's say, Bitcoin locker. So I like this idea of a virus. So I would maybe copy it and paste it somewhere else. But you can generate more and get some more ideas, and you get a new host of characters. And look, the AI is there just to extend you and just to give you ideas. And you will pick and choose and see what makes sense. What is the story that you really want to tell? And then here we have, let's say, another suggested list of characters. So this is kind of what we did in the beginning. So we have the title generation prompt, and we give it the log line, and we pass that through the language model, and that gave us, let's say, 3 suggested titles. And then what we're doing now is we're generating suggested characters as well, using a prompt as well. So now we have, let's say, this 3 different characters. We can continue. So we have Gen Z, who is a programmer, lives with her family. We have Jared, system admin, and we have Harry, cryptocurrency expert. So now we can, create some visuals with Stable Diffusion. And to do this, we get some styles. So this is a part of how to do prompt engineering for image generation, is we want things to look nice. And to get some suggestions, we can go to Lexica, which has a lot of examples of prompts. And I just copied 2 of them here. So to create this image prompt, we just take one of the descriptions of one of our characters here. And then we just add the style prompt to it. So I'll show you a quick example here. So a programmer and hardware hacker, she lives with her family in an eco-commune. So this is, let's say, the description of our character. And these are suggested, let's say, generated images for the character. Now, you need to do a little bit of prompt work. Because these prompts are a little long, we can take away parts of it that are not, let's say, visual, or don't add any visual information to the image generation model. So, for example, where they live, we can cut out that part and just have this part as part of the prompt. And again, just like we did with the stories, we can generate again until we find something that we like. Here I'm having for each character I'm generating 3 potential images. And with prompt engineering for image generation, you can say, okay, I want maybe a portrait of that character. So maybe we can say, okay, so this is a portrait, and there are 2 styles. We can try the other style here by changing this one and seeing if that what kinds of images that sort of yields. And so here you have these pictures of your character, and maybe they just trigger for you as the creator, as the writer, some thoughts about who this character is, how do they fit in terms of how you see them. We can do this with the other characters as well. So we just go to the 3rd character. So this is a little bit of what we did here, is that okay, so I love that this has an actual Bitcoin part in the image. So that's surprising. So what we're doing here is that, okay, we have the prompt, and then we have the suggestions for the how the characters would look, and we like maybe one of them, and so we add that to our let's say list of information that we have about our story. So we started with 2 sentences. Now we have 3 characters. We have pictures of all of them, and then we can proceed. Now, the main meat of a story is just the plot. What happens. So we have the 3-sentence description, but how can we get a longer one? And stories really follow a specific formula. This is the most commonly used. It's very popular structure of stories where it's called the hero's journey, where you start in an ordinary world. The protagonist, the hero of the story, gets a call to adventure. They refuse the call. They meet a mentor. So this is like, most films or stories that you come across fit this in a specific way. And we have a prompt that sort of generates all of these. And so we can, again, using our log line, we have this prompt that you can read here if you want, and it's pretty long. But that generates the structure of our story. And we'll have one suggestion for how this story works over 6 or 7 scenes that follow this this hierarchical, let's say, structure of stories that makes them interesting to us as people. So, all right, we have this might not stop us. So, but I can run you through this really quick. So we have, this is, let's say, the first scene. This is where it takes place. So it's in a cyber cafe on a ferry boat crossing the river. And then this is the ordinary world. And so what happens in the first scene? The 2 are strangers with a narrator on her way to visit family in a commune in the Northwest. And then you can continue to see sort of, it wrote a first scene. And then what happens in the call to adventure? They receive an email, one of them by her online persona, one by, and then so on and so forth. Like it goes through and builds, how do they refuse the call? What do they decide not to do? The kinds of trials and tribulations that they have. And this stops at about 6. The prompt can go up until, let's say, 11 pieces, but for this demo, I made it a little bit shorter. So it gives you a sneak peek of how to let's say, generate the story. And so, yeah, now you can see how our story went from just being this, 2-3 sentences to characters to 6 or 7 scenes to the people that or the images of the characters that we've seen. And then from there, we can take it to the next level, which is describing the locations. So this is something, for example, I've generated previously. Or yeah, we can use this. So we can generate descriptions of these scenes. So this is a place, right? An apartment in Seattle, and then a car dealership. We can have the model, the next prompt writes a description for this place, for this location. And it can be like this. So an apartment in Washington, the description of this place is that it's a sparsely furnished, smoke-filled brick apartment, lights are off. So now more and more, it's fleshing out your story. And if you like this, you use it. If you don't like it, you can rewrite it. Just like what we did with characters, we can visualize this as well. So we can, let's say, take that description of that location and we add a location, let's say a style, image style prompt to it, and generate some images. Let's see how that works. And length is an issue here. Like the issue with Stable Diffusion is that it allows only for about 77 tokens. Maybe version 2 allows for a little bit more. But then we can see here that it didn't really get to the interesting parts of, let's say, the style. So it's not highly stylized yet, but it's just an image description. But you can, that's why I have this code here where you can edit it and add to it, let's say, the style that you want. And I think we will stop here. There's one more prompt in the end that generates the dialogue for each scene. But then this is just a quick look at how you use the latest and greatest in AI on both the text side and image side to just unleash your creativity, to tell better stories, to tell the stories that you feel inside, even if you're not a writer. This just use the AI to help you and extend you. Thank you so much. I hope this was useful.
Yes, Jay, absolutely. It was phenomenal. I have some questions, so please stay with us. As the chat has been dying to know, we've got Hamada asking, if you try it again, should it give you another story? So with the exact same prompts, would it give a different story or would it give the same story over and over?
It will give you different stories because there's a sense of randomness involved in the models. Like you can change the temperature to, if you change the temperature to 0, it will always give you the same thing. But usually we set the temperature, which is a parameter of the language model, to a higher value where there is randomness, which enables some creativity. And like for a use case like this, you need higher temperature values of between 0.7 to 1, where the creativity of the model is important and the diversity in what the model generates adds more interesting ideas.
Okay, Jay, another question we have. Do you know any commercial projects that are currently generating content like this or that work with generating content like this?
So there's an entire industry for generating text. We just saw, companies like Jasper, Copy AI. That's an entire industry around generating articles, blog posts from using language models. Now, with image generation, those models are fairly new. Stable Diffusion only came out in August. DALL-E was on a wait list before that, but it's absolutely certain that it's going to change media in a massive way. And like the best ideas of companies are still in the mind of somebody. Maybe one of you is going to create, the next Google using these technologies, because this is just so early in the life of these technologies that now is the right time to just play around with them, understand the capabilities, deploy them in different industries. So that's why I find it really exciting.
Fantastic. And obviously, we've seen the stable diffusion application there where you've taken it a step further. Not only did you generate the story, but you also generated the art aids for imagining it a little bit better. And Susanna is asking, is it possible to make automatic illustrations to existing stories like books? So can we upload a whole book and have you generate illustrations based on stable diffusions, for example, for the characters?
Yes, absolutely. And I've done that with one of my favorite books. I just went over the first chapter and I was just reading it and, pointed out where the story was describing a scene. Because, a lot of the stories are dialogue, a lot of them are but sometimes what is called world building, where they describe a city or a location or a set or a character. Like you can take that out and put it into stable diffusion. But then you can also pair it with parts of style. So, for prompt engineering, for images, you can say, okay, this is, I don't know, trending on ArtStation. This is, high res portrait of a specific. And so when I think about image generation prompts, there's the subject and there's the style. And the book can give you the subject, and things like Lexica can give you the style that you like, and you can pair the two together.
Incredible. I have to say that this technology is really mind-blowing in the sense that I'm really looking forward to how my children will learn how to write in school, because I can see this completely changing how we're doing. Like the transition from written word to Word and to Excel was a big step, but this is going to be that times 3, I think, and it's going to be super, super cool to see what we're capable of in a few years. Jay, thank you so much. That presentation itself, a whole beautiful lecture on really long story generation. Let's keep proceeding with the stream. Thank you very much.
Amazing. Thank you so much.
All right, guys. So let's just very briefly go over how you should create and connect your team to Lab AI and on Discord. So basically, jump on our website, Lab AI, or our platform. Join your profile together with Discord, meet your team there, come up with 2-3 working concepts. It's usually best to have 2-3 loose ideas, and then communicate with the mentors and find out what's actually possible to be built. Then jump on and try your best to execute a working prototype, working project, and then submit your solutions via Lab AI. If you're looking for a team and you haven't come with one prepared for the hackathon, you can look for potential team members on the Discord, on our Discord server in the Looking for a Team channel, or you can join and create new teams with the Lab AI website. As I've mentioned before, you'll need to connect your Discord with your Lab AI profile. If you don't have one, don't worry, you'll be asked to create one. Discord is free for all users, and it enables voice and text channels for your communicating with your team, for communicating with the mentors, and communicating with us as the organizers. Yep, as I mentioned, the mentor feedback is the reason why this event sets us apart from you just building it at home, I think. Of course, apart from a number of other benefits, but this is the main reason for me. If a mentor says something can be built or cannot with the technology that they represent, it really tells you if it can or cannot. And of course, you can go ahead and try and prove them wrong, but I think that it will bear much better fruits and much better solutions if you follow what they suggest. Of course, as I mentioned, putting the pieces together and coming up with an application of how the software can be used is all up to you. And you can reach out to mentors by use the calling for help in the team page and wait for mentors to jump on and check out what the issue is. And they can help you not only with selecting the initial problem. If you get stuck at later stages, be sure to reach out to them, and they should be available throughout the whole event. Your presentation should contain within what have you built, the demo of the prototype, the process of building the prototype, and potentially a business plan. If you can find a real world application to the solution you build, even if it's just for fun, right, this has been created purely for fun. We want people to enjoy using it. There's no business model. That in itself tells us exactly what the future plans around the application can be and what its potential. Make sure to upload your submission on the lablab.ai team page to make it valid for winning our wonderful prizes. And a very humble request from our team, please, please, please try and keep it under 5 minutes. I know that with a team of a few people or with a number of solutions or high level of complexity, you may require more time, but just given the time constraint of our poor judges and of everybody that will need to review and our staff that will need to review, there's going to be a lot of people watching these videos. So I really, really humbly request that they are around 5 minutes. And how are we going to evaluate you? We're going to look at the degree of completion. So if it looks like a really, really go-to-market product, then that's ideal. Presentation style, so if you're able to articulately and clearly present the whole concept, how much applicable value and how much commercial value could potentially have, and of course the degree of innovation and originality. So if it's another clone of a clone of a clone, it might be better than them, but it won't wow the judges. And then, of course, the technology and how you've put the pieces together, the impact that it could potentially have on the market. Does it disrupt a way that business is done today in any sector? And of course, the overall impression. So if it works all together very nicely and creates a story, and we can present a user story through your submission, that would be perfect. So the prizes for first place is 5,000 in API credits for Cohere and $1,000 cash prize. And for second place, it is 4,000 API credits, 800 cash to be distributed among the finalists. And additionally, all winning teams will get Cohere swag and have the chance to meet the Cohere founder for a virtual coffee. And perhaps, who knows, maybe they'll get to record a video of their demo and be promoted on Cohere's channel, which will give them a lot of reach and perhaps get them to the next level of building a company with this startup. If you need additional help, important to remember that you can find it at our Discord in Generative AI Hackathon channel or in I Need Help channel. Or you can just simply directly message Nasty. She's always super happy and super active within our community, and she's a little ball running around of energy around the office. So we always really enjoy when you write nice stuff to Nasty. It's really great to see it around the office. And with that, I wish everybody absolutely the best of luck. Try to have as much fun as you can. This is a learning experience. This is something that's meant to better the human race. We're all trying to move the ball forward away from, exploitation of resources and into efficiency and, the faster creation. I have a very strong belief that AI can be used for good to eliminate, monotonous tasks and redundant labors from our world and really create a world of abundance and the appropriate allocation of resources. So in that sense, I want everybody who's going to be building with us to really think of how their creations can contribute to the betterment of mankind. It's absolutely the most fundamental thing that we can promote and suggest. And I strongly thank the internal team of LabLab for hosting the event over the weekend, and of course the Cohere wonderful mentors and representatives that has joined us for today. It's going to be an absolute blast, and good luck.
guys, welcome back to our stream. I'm happy to have you everybody here today. I hope somebody will join. We have here a very big screen. We see everything that you write in the chat, so just feel free to communicate, to engage with us in the chat. Guys, we came back with two very great news. First of all, now we'll have lecture about getting started with text generation. So everybody who is new to text generation models, you can now learn how to work with this text generation. It may be extremely helpful for your project. And the second part will have amazing, I wouldn't call it like interviews, but you may jump for our stream and you may introduce yourself if you didn't find a team yet. So you may just tell that about your background, about your idea if you have one, and probably you will find a team on our Discord. So it will be in half an hour, so feel free to jump on the open voice channel and we will like switch you to the stream and we'll talk with you around like 2 minutes and you will be able to pitch yourself and to tell about your background and join the team. And now I want to introduce really amazing lecture speech that can be extremely helpful for your projects. And the speaker today will be Mer Amr, who is a neural language programmer in the Cohere. And he is really passionate about alternative ways of education. You will use in visuals, using gamification and storytelling. And now he will give us amazing talk about, as I told, getting started with tech generation. Guys, enjoy.
Hello, my name is Mio, and today I'll be sharing about getting started with text generation with Cohere. There are three main items that we'll cover in this session. First, we'll look at how to prompt a text generation model. We'll first understand what a prompt is all about, and then we'll see how it can be applied on two types of models that are available on the Cohere platform. Next, we'll look at how to control the model's output that you get with a number of parameters that are available at your disposal. And finally, we'll look into a few prompt and application ideas so that hopefully you can get started on your ideation for your projects. We'll look into a range of use cases that are possible with a text generation model, and we'll also look at the range of teams and industries where this can be applied. First, how to prompt a text generation model. So there are two main ways on how you can influence the output of a text generation. So when you work with a text generation model, you provide an input, the model will process the inputs that you provide, and then it will provide a response. So there are two ways and there are two parts where you can affect what output that you want to see and the response that you're going to get from the model. So the first is prompt design, which is what we're going to cover right now. So prompt design is at the heart of working with large language models. It is important that you come up with a good prompt in order for you to get exactly what you want on the other end, which is the output that you get from the model. So the prompt is what you create and what you provide to the model as an input to provide a context for the text that you want the model to generate. It is both science and art. So the good thing about it is that while there are a number or a few ways that we know in general that how prompt design works, but at the same time, on the other hand, there's also a lot of room for imagination, room for creativity, room for experimentation. So that means there's a lot of ways that you can play around and experiment with prompt design so that you can come up with exciting applications for your project. So with Cohere, there are two types of generative models. First, the first type of model is the type of model where you prompt by instruction, and the model that you use for this is called command X large. We'll go into the details on how you can work with this model and the rest of the models in the next part in the subsequent sections. We'll also talk about the other type of model, which is the group of models that you provide examples for it to generate the kind of output that you want to generate. So this family of models include the X large, large, medium, and small models. So let's talk about the first one, prompting by instruction. So in simple words, you're telling the model what to do instead of showing it what to do. For this, use the command X large model that we talked about just now. And the kind of output that you get is more open-ended, and there's going to be more variety in the output format compared to the latter type of prompting, which we're going to look at after this. So it is very simple. If you look at the diagram, what you provide is a set of instructions. It can be a very simple instruction. It can be a very detailed instruction. It depends on what you want to get, and the model will generate the output for you. So let's look at the simplest possible instruction that you can provide, which is just a one-line instruction. So in this case, what we are doing, so if you look at this screenshot, this is a screenshot of the playground that we'll actually go into in a short while. But for now, we'll just look at this screenshot for this first example. So this is the playground where you provide the input and you get the output in bold. And as you see on the right hand side, you have this command X large being the model that's being used. So the simple instruction that we provide here is write the story plot about a writer who becomes trapped inside her own book. And the model duly returns the plot that, if you go through, it looks very plausible, talks about the writer, let's say the first sentence, as a writer, she had always loved the idea of being able to escape into her own world of fiction, and it continues to talk about the plot. But what you can see, the plot that's been generated is good enough, but probably what you need to provide is something that is a bit more specific, because if you look at the generated text, it just continues, but there's no specific way of concluding the plot. So in this example of a fiction writing, so you may want to provide further instruction if you want to generate a story plot. So what you may want to do is to tell the model specifically now with an additional instruction to split the plot into the following story arc. So you have the exposition, rising action, climax, falling action, then a resolution. And then the model understands what the instruction tells, which is writing the plot using this story arc, and then it provides this plot from start to finish according to the different sections that you provide. So if you look at how we can use these prompts, if you keep on layering your prompt with more specific instructions, you will get an output that is closer to what you want. So there's no limit on how long the prompt can be. So there is an overall limit of 2048 tokens that includes the input and the generated output. So one token is roughly one word is roughly 1 or 2 tokens. So altogether there are around 2000 tokens that you can have in one generation. But yeah, so you have a lot of room to play. So you can have a prompt that is as specific as possible according to what you want. So let's look at the playground with another example on how you can do this. So in this case, this is how the actual playground looks like. So you have the main window that you saw earlier, and this is the right pane that we'll cover later on what are these parameters about. And on the left, you have these presets, which are the prompts that have been saved. So in this example, I've saved one prompt, which is add copy, a very simple one line instruction, generate a social add copy for the product wireless earbuds. So in the same way that we saw earlier, so it generates this add copy according to what we need. This is great, but perhaps you want to be more specific. And here I have another preset that I've created. So the copy consists, I've added another line of instruction. The copy consists of 4 parts: attention, interest, desire, action, following this AIDA framework that is common in copywriting. So hopefully the model will be able to generate an output how we want it to be. So yeah, it doesn't finish because I've set the maximum number of tokens to 100. So if I keep on generating to more outputs, so you can see that now it is generating this copy according to how we want it to be. So you have seen two examples on how you can achieve what you want in terms of the output by layering your instructions to be as specific as possible. And this is just one example. There are many more ways you can play around with the prompts. Another example is to have instruction plus some context. So this example, the context that we're talking about here is a product in which there is a description about the features of the product, which is an app that automatically transcribes meetings. So what we want for the model to generate, which is the instruction, which is to turn the following product feature into a list of benefits. And to be more specific, group them into 3 types of benefits: functional, emotional, and social. Okay, so now you see that it generates this output based on a context and instruction that we provide. So this is what we see here, where you can have one simple instruction, you can have more specific instructions layered on top of each other, and you can also have a format where you have a set of instructions or a line of instruction plus the context that you want the instruction to refer to. So these are like a number of ways on how you can construct or design your prompt. But there are many more ways. Again, the good thing about it is that it's a combination of imagination and iteration. So the whole plan is for you to keep on iterating, think about new ideas, just play around with the playground, and hopefully you'll be able to get to what you want to get out of the model. So the other type of model that we have, as we discussed earlier, is a model where you prompt by example. While the prompting by instruction that you saw just now was quite straightforward and quite simple, because you can even start with one line of instruction. Sometimes you want the output to be a bit more specific and to be of a similar kind of pattern, tone, especially when you're generating it in something many times. Let's say you want to generate product descriptions of thousands of products. So you want each of the descriptions to be of a similar style. So in that case, if you were to use that earlier model that we look at just now, you can still achieve, you may still be able to achieve what you want, but with this other option is going to be a bit more simpler for you. So let's look at how you can do that. So instead of telling the model what you need to do now is to show the model what you need to what it needs to generate. So these are the 4 different models that are available. As a rule of thumb, the larger models provide better quality output, while the smaller models provide a faster latency. So that means you get a faster generation once you click on generate. So the output is more close-ended and the output format is more predictable. So the general format that works well is you provide first a description of what this whole prompt is about, and you provide an example on what you want the model to generate, and then you have a stop sequence to each of the examples. So stop sequence is a set of sequence that you can provide to the model to indicate that you need the model to stop at a certain point. So let's look at this via an example. So in this case, we have this product description where, given a product and keywords, this program will generate exciting product descriptions. And we give 2 examples of a monitor and a surfboard, and we want the model to generate the description for this headphone. So we provide keywords and the model then generates this output, which is of a similar style with the other 2 that we have provided. So in this case, we can keep on generating similar style for the rest of the products that we have in the list in this case. Another example is haiku. So with haiku, typically what you want to generate or to get is typically 3 lines, or 3 lines where roughly they are of a similar length. So here what you provide is a few examples of haikus, And then here you provide a few keywords, write a haiku about software and magic, and then the model generates this haiku according to the pattern and examples that we have provided. Another application will be like in chatbots. So this is an example where it is a user talking to a fantasy wizard, where we want to create the persona of the chatbot that someone is talking to. So here the persona we're talking about is a fantasy wizard that provides an answer to the questions that a user is asking. So you can create chatbot personas by providing a few examples of what kind of tone, what kind of style that you want the chatbot to write about. So we have looked at how to prompt the models via these two ways of prompting. So the second way on how you can control the kind of output that the model generates is via the parameters. So you see the parameters on the right hand side of the playground. There are a few of them, and they can be grouped into three main categories. So first is when to stop. So the most straightforward is you specify the number of tokens. So as we discussed just now, roughly speaking, one word consists of 1 or 2 tokens. So this is what the model does as it takes the inputs that we provide, turn it into tokens, and then returns the text and output. So we provide the maximum number of tokens to represent the number of words roughly that we want the model to generate. So the other way that we have also covered earlier is stop sequences. So for example, if you provide double dash or any set of sequences that are typically not a sequence of text that you see on a normal generated text, you can provide that to indicate that this is where the model should stop generating. And if you are talking about the instruction the command model that we looked at earlier, where we prompt it by instruction, you can because it doesn't have a pattern of examples, so maybe we can't provide this dash or set of symbols to show when to stop after each example is being generated. You can use like a period character, new line to indicate that the model needs to stop the moment a paragraph has been completed or a sentence has been completed. The more interesting one is to the set of parameters that you can control and modify to tell the model whether to be more creative or more predictable. But before looking into the parameters, let's understand what likelihood is, because everything revolves around likelihood when you play around this set of parameters. The concept is actually very simple. So when you provide a prompt to the model, in this case, I like to bake, the model will decide among all possible tokens that it sees, in which case, in this case, is in the thousands, which tokens are more likely to be generated after this sequence of words of I like to bake. So in this example, we see that cookies is at the top of the list, which is the most likely token to be generated. And somewhere down the line, you also get other tokens, in this case, for example, chair, which is not very likely that a chair will follow a prompt of I like to bake. But it's there, and there's still a chance for the model to generate this word and any other words other than the topmost token with the highest likelihood. And the whole point of adjusting the parameters is to increase or decrease the chances of these other tokens to appear after this prompt. So how do you do that? So first is with the parameter called temperature. So if you look at this is a rough illustration on how it looks like. So if you look at the center illustration here, you see the list of probabilities. So vertically, it is a list of tokens. So it will go on until all the possible tokens are listed. So if the initial set of probabilities are like this, if you increase temperature, what you do is that you somehow nudge the other tokens to have a more higher chances of being of being selected as the next token. So whereas if you reduce the temperature, you reduce the chances of these other tokens, and you have the topmost token to be almost always being chosen every time. So that means if you increase the temperature, it will be more random, but if you reduce the temperature, it will be less random. So in other words, increasing temperature can be associated with the model being more creative, and decreasing it, making the model more to be more predictable. So the other set of parameters are top K and top P. So whereas temperature looks at which token to choose, top K and top P looks at how many tokens to choose from. So if you reduce the number of K, which is the number of tokens to be considered, let's say you just select K as 3. So only the first 3 tokens will be considered as generation, whereas if you increase it, you're opening more options for the model to choose from the range of tokens available. So similarly, if you increase top K, the selection is wider, which means that chances of more random output is higher. And if you decrease top K, the output will be less random. Top P works in a similar way to top K, except that while top K looks at the counts of tokens, top P looks at the probabilities, sum of probabilities of these tokens. So similar way of filtering this, just a different way on how it is being calculated. So yeah, let's look at one example. So here we have, with the XLarge model, prompts that generate startup idea given an industry. So what we have now is a few examples of industry, startup idea, and a startup name, and we want the model to generate an idea given this industry, which is productivity. So here are the settings for temperature, top K and top P. So for top K, what you see is 0, which means that top K is not used. That means all possible tokens are available to the model. So let's generate with this current settings with temperature 0.4. Okay, personal assistant that helps you schedule meetings. Fair enough. So what you want to do now is, let's say you want the model to be more predictable. So what you do is to reduce the temperature, and actually you can even change the top K to 1, which means that you want the model to be very deterministic. Like what should happen is that every time you should generate the same thing. So here with temperature 0 and top K of 1. Okay, so a tool that helps you manage tasks and projects by automatically creating Gantt chart. So if I generate this again, I get the same thing, the exact same thing. And no matter how many times I click, I'll get the same thing, because what I've done was to reduce the temperature to 0 and top K to 1. So this is being is deterministic. That means as predictable as it can be. But if you want it to be a bit more creative, let's say 0.8 as a temperature. So the range is between 0 and 2. And top K, let's change it back to 0, which means that all tokens are possible. Here now you get new ideas about task management app. Let's make it a bit more, let's say 0.9. Okay, keypad that can be set to thousands of different shortcuts based on each user preferences. So it starts to explore like very broad range of ideas. What I've done earlier that I'll not cover here, but if you go within this range of 0.2, 0.3, the ideas that normally would come would be typically to-do lists and your typical productivity, personal productivity applications. But as you increase the temperature, it starts to get more interesting and more creative. So of course it depends. These settings depends on when is suitable to be used. In this case, when you want to generate ideas, maybe you want to get it to be more creative. But in other cases where, for example, you want to summarize something, maybe you want it to be more less creative and more predictable, and according to how you want it to be. So that's how you use this set of parameters to control the creativity of the model. And finally, there is a set of parameters that you can use, frequency and presence penalty, to reduce the repetitiveness of the output, where it gives a penalty to tokens that have been present before. So you can also use this to your advantage. And finally, we look at a few prompt and application ideas. It helps to understand, or when you want to ideate on stuff to build, to understand what the model can do, and at a high level, what the model can do can be bucketized into these 4 broad range of use cases. So the first is generate, which is basically the biggest portion and the most that we have seen in the examples earlier, where we just provide a prompt and it just does a completion or continuation or response to the prompt that you provide. But there are also 3 other specific ways you can utilize prompt design to create different kind of use cases. For example, to summarize. So in this case, you provide a context, you provide an instruction, for example, if you're using the command model, and then the model will generate the summary. You can also use it for rewriting or paraphrasing a text that you provide just by changing the prompt. And finally, by designing the prompt, you can also get the model to extract information from existing text. So we'll look at a few examples in a short while. When it comes to teams, there are many teams, industries, and verticals that all these can be applied. But broadly speaking, you will see a lot of out there teams around copywriting, social media, productivity, like writing emails, creative writing, of course, that we have seen in the first example earlier, and it goes on. There are many possible teams that you can apply text generation into these verticals. So if you already have ideas on what to build, then that's great. But if you don't, maybe a good way or a good exercise that you can do is try to match or try to mix and match and try to map between the kind of use cases and the kind of teams that you would like to go into and try to ideate based on those. So there are so maybe that's a good starting point, and let's look at specific prompts and examples that maybe can help you get started with ideation. So the first is summary that we talked about just now. So in this case, it's using the XLarge model. So we provide a couple of examples of a passage and the TLDR summary. And yeah, with this, the model will generate the summary based on the passage that we provide, which is about a phrase warning in this example. So when it comes to rewriting, you can think of it in terms of many different ways, like correcting transcriptions, correcting spelling mistakes and grammar and things like that. In this example is to rewrite blog titles to make it more interesting. So this is using the command model, which is where here we are telling the model to suggest 3 alternative titles with a better marketing copy for this title that we have given, learning to play chess. So yeah, surely it can do better. So it provides 3 examples or 3 ideas on blog titles that can replace our original one. where the tone is inspirational, where we provided it as part of the instruction. And finally, extracting entities from text. So in this case, from legal agreements. So we can set up the problem in such a way that we give examples of extraction in many different ways. So in this case, it's extracting entities from legal agreements, but you can apply it, for example, for extracting a list of skills from resumes, or extracting movie titles from a passage or description, or extracting keywords from articles. So there can be many ways you can apply this extraction use case using text generation models. So let's look at a few more other examples. This is a brainstorming use case or theme where in this specific example is generating the business model canvas, where if you want to like brainstorm about this product, which is a satellite broadband service, one way you can do this is using the well-known business model canvas, where you are splitting the items into like 9 different buckets. So you can just provide this to the model, and with this prompt, it does work. It provides this different information. It gives you ideas on what value propositions, for example, that this service provides, the customer segments, channels, and actually the list goes on, and it completes until all the 9 buckets have been generated. Another example is generating a pitch deck. This is using the command model, generate a pitch for an AI chess tutor, and we specify what must be included in the pitch. So problem, solution, features, and so on, and we get this generated by the model. Another interesting application will be turning keywords into email. So when it comes to productivity, it will be good to just tell the model roughly what you want to write, and then it will complete the full passage that you want to create. So here we provide using the X large model, we provide a few examples of keywords and the full email, and we get the generation here for a launch of new fitness watch series. Yeah, and finally, creative writing. We have seen one example earlier. Here it is an example of a Victorian style writing, where we are asking a model to generate a different kind of writing, which is following the Victorian style of a simple phrase of "I'm feeling okay." So here you get this very elaborate and beautiful expansion of the same idea, but in a different style. So in this case, also we provide a couple of examples of like a normal English phrase with the Victorian style counterpart. And that's about it. I hope that has been helpful, and happy hacking.
Thank you so much for being with us for this talk. It was really amazing, guys. If you have any questions to Cohere regarding the model or to the speaker itself, please go to Cohere Discord or go to our Lab page to find the LinkedIn of the speaker of the more, and you may write to him directly. I just want to remind that now we have process of team creation, and in 5 minutes we will start short introduction. So you may now jump in our open voice channels, and in 5 minutes we'll come back. Me and Nasty together with me will ask you questions to help you find your team if you didn't find one. And thank you so much, Cohere, for giving us such amazing speakers. And guys, still, if you have any technical questions, feel free to write to our mentors and to our technical helps chat. And if you have some questions regarding to Cohere, go to their Discord and ask their experts. We'll be back shortly. guys. We are happy to back to you with the team interviews. We have two people today who are looking for a team. If you're also look for your team to join, and you want to join us and to tell about your expertise, to tell about your background, maybe even idea if you have one, and to find the right team for you, we are welcome to join Open Voice channel, one of two, doesn't matter, and we will just kick you to the stream. And for now, we have our first participant. Hi, do you hear us? Hello. I just don't see. Hi.
Hello.
Hello. Do you hear us now? Cool. Happy to have you here. If it will be comfortable for you, please turn on your camera. And you have your 2 minutes to present. Hello, nice to see you. No, maybe
No, just like introduce yourself to find your team. Maybe someone who has already team see you and will invite you for to team up. So yeah, just tell about yourself, how you can be useful for a team from business side or more from technical side, for example.
Okay, awesome. So I will, my name is as noted. I'll give a background about myself. I've been working in AI. I have and I'm really interested in working more towards generative AI. Apart from that, I do have a team right now. It's called AI Banana. And what we are planning to do is we want to use generative AI for product design. So a lot of product design, for example, starts from a sketch or starts from a very basic prototype looking kind of a design. And what we would like to do is that if we were to able we were be able to give a model, an image of let's say a car, and how can we use generative AI to modify the design of the car just by some prompts like or make it a little less boxy or make it a little more aggressive, more radical design. Uh, so that's what the kind of idea I have. I would like to work on. Um, I'm s- I, s- I do have a friend of mine who has joined that team, but I'm still looking for more people. So yeah, that's about it.
Great.
So do you have your own team already created in Lab and you're looking for members, or are you looking for join existing team?
I've created a team already. It's just me and a friend right now who I know. But I am still looking to have more members in the team. I don't know what kind of skills would be required for such kind of a thing. My friend is a mechanical engineer, so that can be great. I have a lot of background in Python programming, deep learning. That can also be helpful. I'm still looking for members in any background, anything possible.
Great. Can I ask you to insert the link to your team in our looking for a team channel? So yeah, they people may join.
Go to the link
Yes.
here and join
Yeah,
directly.
join you. Yes.
It will be much more helpful even for you. So yeah, just like copy link for your team from our lablab.ai website. In the looking for a team channel, and people can join. That was actually my second question, but you already answered it partly. What type of expertise are you looking for? Are you now looking for more business people that you see you missing, or you need still a lot of technical people?
I would still need possibly someone from a business background, design background, and a little bit more of software. Software would be main. Where so what I would want to have is any kind of a platform, website or anything where I can upload a image and then just given prompts to change the design. So I think a little bit more on the software side.
That's great. Okay, we got you.
I have
Yes.
I have shared the link on the looking for team channel,
Looking for
and
a
I
team
think
channel, yes.
Yeah.
yeah, I think that some people had some issue in actually joining the team. Uh, I
So
don't know
in
how
that
can I
case, I
fix.
will take our mentors and they will able to help
Yeah,
you.
even we can help.
Yes,
If you have
yes.
some like technical issue, feel free to write to us or tech mentors, and we will fix it. We didn't know about any issues on the website for today, so everything should work. But maybe people didn't connect the Discord or didn't sign up for the event, like from the email they use. It might be the case. So just guys, for everybody who is watching us now, just make sure that you connected Discord to your profile in LabLab. It's very important to have a proper communication and then to communicate you in case your team will win or we need some information for your submissions or something, because we usually have the issue that we have very good teams, very great ideas, but they didn't connect Discord and we can't communicate with this team. So just make sure that you connect Discord to your LabLab profile. And also if you are on your LabLab, just make sure that you enrolled to this event with the email you like using. You might be just like without how it's called, like when you not log in to the website, so you signed up but you didn't log in when you're on the website. So just make sure that you are, that everything works good. And for you, thank you so much for sharing with us your idea and that you have a team that's very great. Just make sure to share the link for your team on our Looking for a Team channel, and we're
Okay.
more than happy to help you with finding your teammate.
Yes. And remember that you can have max six people, six
Yes.
members in your team. So if you already have six members, so now it's impossible to join more.
Okay.
Great.
Thank you so much.
Thank
Bye.
you. Bye bye.
Bye.
Guys, we see that a lot of people really found their teams today. We do not see now a lot of messages that people are looking for one. So yeah, in case you have any questions or you have troubles with finding your team, or even if you have some website issues, feel free to reach out to Nasty. She's like she loves to communicate with you. You may reach out to me as well, and we are more than happy to help you guys. And so hopefully everybody already found their teams. Have amazing
I
process
think
of
yes,
work.
because we all our Discord were very active. Thank you guys, and I hope I help you. I was helpful for you today evening to find your team. So yeah, but in any case, if you still need your team or still need members, feel free to ask me or our mentors for help, and basically write about that you need teams, write in looking for a team channel. Yeah, it's more than helpful.
Yes. And I just will quickly announce the next stage of your process of working on your projects. When you find your team, then you will work on your concepts, on creating the idea, and then to maybe discuss with mentors in case you want it, your concept, your idea, so they may give you this okay go, and you may start working on the project. That's it. That's it. We want to wish what?
Yes, but we have one more.
No, we do not have anybody. Probably this guy
Okay.
found the team.
Okay.
Yes, I'm just monitoring the chat, so nobody is looking for a team now.
So that's
very
great.
great.
That's great.
That's
Really.
very great.
Thank you,
Guys,
guys.
stay active and talk to you tomorrow. We have a very like busy schedule for
Yeah,
tomorrow.
tomorrow we also will have short yoga breaks with me. So jump in. We will warm our body and have some relaxing time. Yeah, because I know you are working hard. What else? Yeah, you can communicate in our channels. Feel free with each other. So these channels created.
Send memes.
Yeah, I will send you memes from time to time. Yes, so this channel is created most of all for you, so you can share with your knowledge some useful links, some I don't know, if you'll find some videos, feel free to share it with others. So yeah.
And don't forget that if you need any, like if you have any technical question or you need some inspiration, go to our tutorial page on the website, which is lablab.ai/t, and you will find there really amazing examples of how you can work with Cohere and what apps you can really create. So get inspired using our tutorials, and we'll talk to you later.
Yeah, you also
Yes?
can go, sorry, you
We have a
also
lot of
can
tutorials.
check our previous Cohere Hackathon Thanksgiving and check in the submissions. So yeah, you may see how it looks like. Yes.
Get inspired and work hard on your projects. We are here to help you. See you guys on the tomorrow's stream.
Yeah, bye.